I just wanted to say welcome and thank you for coming along to this Maths for Girls event. We genuinely, as a charity, feel that young people having a good grounding in maths is incredibly important for their future careers, but more so for girls because we know from research that often they stop pursuing maths after they finish their GCSEs, and that can have so much impact on their future careers that they don't even consider that age. So we're very glad to see schools coming along to take part in this and to hear from some of our fantastic role models who will tell you what it's really like to work in a career that uses maths. So thank you for coming along. You will have your video and your cameras off. If you get any questions, please just pop them in the chat box. And with that, I'll hand it over to you, Sharon.
Hi everybody, and just to echo what Alison said, you're all very, very welcome. We're so happy to see students on the call. We know we've got quite a few students of Science Mastery on the call, so you will be familiar with our Scientists in the Spotlight resources within the curriculum. And this session aims to be a sort of a live version of that resource, where you're going to hear from currently working scientists and those who use science or maths in their careers. And this session will be, as Alison mentioned, focused on the topic of electricity. And if you're studying Science Mastery at the moment, you will be either soon or at the moment studying something to do with the topic of electricity. And so this will be particularly useful to you. If you're not studying the Science Mastery curriculum, you may not be currently looking at the topic of electricity, but you will be at some stage. So keep this in mind when you get to that topic. So without further ado, I'm going to introduce or I'm going to ask our speakers to introduce themselves just very briefly with their name and what their role is and where they work. And then after that, I'm going to ask each of the speakers to give us a little bit more of an in-depth overview of their role and all of the interesting things that they do and get up to every day. So can I start with Candice, please?
Sorry, I couldn't find the mute button. Hi, I'm Candice, and I'm an engineering technician at CMAS, which is part of a local technical college.
Fantastic. OZAK?
Hi everyone, I am OZAK Isu. I am a technical project manager for research and development at HILTI, and I'm currently speaking to you from Switzerland.
Fantastic. Victoria?
Hi, I'm Victoria. I'm a process engineer here at Vision ASC, and I've also worked with the Faraday, which is like the government body for batteries.
Amazing. And Diana?
Hi everyone, I'm Diane Mehta. I'm a senior scientist and I currently work for British Volt, where we're involved in creating battery materials for electric cars.
Amazing, thank you so much. I'm looking forward to hearing more about each of your roles. Just before we start, I'd like to say to the students and teachers on the call, throughout these presentations, if you have any questions or students have any questions, please do post them in the chat and then I'll ask them of our speakers throughout. So I'd encourage you to ask any questions that come to mind and we'd be more than happy to answer those. So from now, each of the four speakers are going to have around 7 minutes or so, but you know, no panic if it's a bit longer, to talk about their role, what they do, and just to share some more information about that with you. So we'll go in the same order as we did before, just to keep things simple. So if we start with Candice, that would be amazing. I can't hear you, Candice. I wonder if that's something with your computer. Not yet. Nope. It was working a moment ago, so I don't know what happened. Should we go along and we'll come back to you? Yeah, let's go along. OZAK, maybe? Thank you.
Yeah, sure. I've prepared 4 slides here to just introduce myself quickly. And it's more to give you a background into how I arrived at my current career. So hopefully you can see my screen clearly. Yes, correct. So I'm OZAK Isu. I'm an electronic and electrical engineer, and I'm from Nigeria, from Cross River, which is the southernmost part of Nigeria. and we live quite close to the ocean here. So where my family lives is somewhere there, if you can see my mouse. Why I chose to study electronic and electrical engineering is because growing up, I didn't have access to reliable electricity. So if you see the pictures on here, there's a candle. So I went through all these stages in growing up. I used to use a candle to do my homework, and as my parents earned more money, they were able to get kerosene lanterns and subsequently get rechargeable lamps, which they took to their office to recharge and then bring home for me and my siblings to work. And eventually they earned enough money to have their own diesel generator, which is kind of like the goal for most households and businesses in Nigeria till date. So Nigeria is one of the largest oil producing countries in Africa. It is the largest in Africa, actually. However, we don't have constant access to electricity. Another problem with generators is, besides air pollution, there's also noise pollution that comes with that. And I just put a picture of some of the air. So this is someone's palm when they park their car and they wipe their windshield in the morning. You see how black that is. So that's the kind of air people are breathing in areas where oil is being, shall I say, extracted. It's not done sustainably. And growing up, I just always wanted to, be a part of fixing that, or just have an understanding to be able to work in the power sector. So that's what drove my motivation to become an electronic and electrical engineer. At school, these are the subjects I studied. I studied physics, maths, geography, further mathematics, English, economics, computer science, chemistry, biology, and agriculture. I've highlighted the top 3 because those were the 3 subjects I went on to do in my A-levels. So I went through the university route, which is you do your primary education, secondary education. So most of you on the call today are probably around this phase in your life, 11 years old to 16 is when I was in high school. And this is my sisters and my parents, basically on my graduation day from high school. But I ultimately went to college, to A-levels, because I knew I wanted to go to university. But I always like emphasizing that university is not the only route to a career in electronic and electrical engineering, or any engineering for that matter. There are apprenticeships, which I really encourage you to look into. I didn't have that opportunity because as an international student in the UK, university was the only route available to me. So after my education, up till age 17, I moved to the UK for my undergraduate degree, and I studied at Loughborough University, where I studied electronic and electrical engineering. I graduated with a first class, and the university gave me a scholarship to go straight to my PhD. Now, this slide is very busy, but it kind of summarizes my entire professional work. And why I put it all on one slide is to highlight with electronics and electrical engineering, I'm able to dip in and dip out. So for my PhD, I looked at electronics, how we use sensors to detect damage on wind turbine blades. So wind turbine blades that generate electricity for us. How can we protect the amount of money that is invested in these sorts of projects? Is there a way the blades can tell us that they are faulty before they actually fail? And I used a sensor called a MEMS accelerometer. They're really tiny. If you see them next to the £1 coin on your top left, they're really small and they're used in smartphones. And because of the increased number of us who have smartphones, these chips have become very cheap and affordable. So using those to try and detect when there is a damage or a crack on a wind turbine blade is what my PhD was about. After my PhD, I went to get a job, and I got a job in construction. So I joined the construction industry in 2014, designing really large national and international projects. So what that involved is, again, looking at electrical building services specifically. So how does electricity get to your site? How is it distributed within your building till the actual electricity that comes out of your socket for you to be able to plug your computers and your smartphones? And I worked on a wide range of projects, including projects in Dubai, a lot of schools across the UK, but also offices, hospitals, you name the type of building. So electrical building services, again, is on the electrical side. So you're using electrical distribution, power generation, your lighting design, your fire alarm in your building, security and access control. I did that for 4 years, and then I was kind of missing research. So I went back to electronics again. And in my third job, which was at BRE, the Building Research Establishment, I was working on research for the UK government on how we use sensors to collect data about buildings. So it kind of merges the two together into one, the sensors from my PhD and now my experience in construction. I think what I like most about working in construction is that it is vital to every part of our society. You think about it, where we live, at home, our schools, where we study, and offices where we work, where we go for leisure. 90% of our lives is spent inside buildings. And so to be part of such an industry, I feel very proud when I work by projects or buildings and know that I contributed to this particular project. Currently, I left the UK in January 2021. I got a new exciting opportunity in Switzerland, in Liechtenstein actually, but I live in Switzerland across the border. So Liechtenstein is a very small country on your map. If you look at the map of Europe, it's right in between Switzerland, Austria, and Germany. So it's landlocked. And I work for a company called HILTI. HILTI is also in the construction space, and they actually develop quite a lot of tools to make work on construction sites safer, faster, and quicker. And I've just put some pictures here. So I work as a researcher in the corporate research department, looking at the latest innovations. And one of the latest ones we launched is JBot, which is a construction robot that helps people on site do work at height that would traditionally have a negative impact on their health. Other examples we have are the exoskeletons that support your back, for example. And there's a lot more I'm working on, which I can't discuss in full today because it involves a lot of protecting of the ideas through patents. But I'm happy to take any questions you have. And I've been here for just over 1 year, and I love living in Switzerland and a new challenge. And I think that's a beauty of engineering. It's very fluid. It's very diverse. I started off in electronics, I'm doing electrical, and it helps me move between these different spaces. Maths has been a key thing that's helped in that, like I showed in my first slide of the subjects I did. Every day I use arithmetics in one form or the other, or algebra to conduct my daily tasks. But last but not least, in my free time, I am a video host for Climate Now. I recommend you check it out if you're really interested in topics around electricity and energy. So I do a lot of videos with experts from around the world on the different types of renewable energy on offer and the different types of technology that would help us towards a cleaner and more sustainable future when it comes to energy. Thank you very much, and I look forward to discussing careers in electricity later on if you have any questions.
Amazing. Thank you so much, OZAK. That was really, really interesting. And it's also really interesting to see your journey into this career. I think that's something we don't hear about very, very often on these kinds of things. So that was fantastic. Thank you. So yeah, if anybody has any questions, I'll say again, please do post in the chat and we'll have a bit of a question time at the end. And for now, we'll move on. Let's keep going through the same order. We'll come back to Candice at the end there with Victoria.
Hello, can you hear me?
Yes.
Fantastic. Right, I'll just get my screen up. I don't know how I'm going to follow OZAK, but we'll give this a whirl. And can you see my screen okay? Yeah.
Yes, we do. Yeah, we got it.
Right. Great. Let's see if I can make it a bit bigger as well. So I've kind of went the other. Let's see if I can. I can't take my subtitles off. I kind of went the other way around my presentation at OZAK, but I'll go through what I do now, what our company does as well, and how that relates a lot to what you've learned at school and what you are about to learn at school. So I'm Victoria, I'm 25, and I work at a company called Envision ESC UK. So on the right-hand side, you can see that I've put really brief bullet points of what we do. So the overall company in Envision Group, we are a global company and we make wind turbines, solar, energy storage, electric vehicles, and then we also do a software that manages everything together. So if you imagine how iOS works on iPhones, we have something that is very similar, but this is in terms of smart and renewable technologies. It communicates between if you've got a wind turbine, if you've got a solar plant, and these are big companies that use these. So then if we go into Envision ESC, so we are the electric vehicle designer and manufacturer. So we predominantly at the minute work with the Nissan Leaf. So we used to be part of Nissan, but going forward, we've just signed contracts with really big global car manufacturers. Nissan we've signed Mercedes now in the US. So, and then we've got new plants being built in the USA, China, Japan, France, Spain, us in the UK as well. So we're a massive, massive company globally. So then the UK you can see some brief numbers there. So we powered about 40,000 Nissan Leafs last year. And to do that, it was we'll go through about 8.5 million cells. So you can see on the bottom diagram there what a cell is. And I've got one here, I hope you can see. So this is a cell. They're about the size of a piece of paper, and obviously you can see these aren't like your batteries that you find in your TV remote. And the reason that us as a company went through this design was because you can imagine when you're using your phone, it gets really, really hot. Whereas because of these a big surface area, the heat dissipates a lot better. So that was the reason behind this design. And this design we came up with didn't come up with. We were the first ones to mass produce in 2010, and we're still running now. And then they get put into a module that looks like this. So my job every single day at the minute, as you can see on the top there, I went from cell process engineer to customer engineer to module engineer. So in cell process engineer, I looked after part of the factory that made these. And basically my job every day was to look at what's going wrong, what's going right, and how can we make the wrong things go a bit better. I then worked for customer engineering, and so I worked for our global company, and that was working with R&D and with our all of our sister sites to see what do our customers want, how can we get this actually up and running. And then module engineer, I now do the same thing as cell, but I do with them with these heavier cans. So I've put on here, how does STEM relate to me every single day? So I use maths. So as an engineer, you are a problem solver, and the first thing you need to do to solve a problem is to define it. So instead of describing stuff really vague, the best thing to do is to calculate it. So I've put a couple examples on screen. So instead of saying something's big, tell them exactly how big it is. And to be able to do that, you have to be able to calculate how big it is. And then once you define the problem, you have to be able to understand why it's happening. So we do a lot of fault finding analysis in my job. And the rule of an engineer is always ask why. So at the end of every sentence, we go, but why is that happening? And why is this happening? And then using technology, obviously we're all sitting on Zoom today. A lot of your work in life will be using Zoom, using emails. So there's a lot of skills that you think you just take for granted, but they're actually really, really important to get right. And the one thing I've put on the bottom of this slide is like the most important takeaway from me is that as an engineer, people think that you always have the answers, but that's not the point. The best thing to do as an engineer is to know who will be able to find it out. So my best thing that everyone says to us is, do you know what the answer to this is? And you go, no, but I do know who will know. So I'll go on a little bit about how I got to where I am. I've put a couple of photos on here just so it wasn't completely boring to look at. So in year 10, I done my first ever work experience at Nissan. And I went round HR, went round purchasing, went round all the different departments. And it was basically in year 10 that went, I actually really want to be an engineer, and I don't know how I'm going to totally get there, but I'm going to get there nonetheless. So I left school in year 11 and then went on to study maths, chemistry and physics and further maths. I dropped further maths after AS year, it was just not for me. And then I got 3 years in chemistry, physics and maths. And then as well as doing that, I went back to Nissan and started working in battery plant and just get a feel for his engineering, definitely for me. I then left sixth form, started Newcastle Uni. I started doing chemical engineering. And then alongside my degree, I started a paid work experience with Nissan. So this is when I started in cell. So alongside my studies, I kind of worked. It took me a little bit longer to get my degree, but it was definitely worth it just because the amount of experience you get, like actually being in industry, is nothing compared to uni. I then graduated and I started with the Faraday Institute. So this is when I started as a customer engineer. And I also worked with the government in trying to feed back to the universities of like what we're missing in terms of electric vehicles. So everyone wants an electric vehicle, but not many people actually know how they work. So I worked both with our HR and our R&D and trying to get more of this knowledge fed back into schools. And then the last thing is that my fellowship year ended last year and I've started as a process engineer last year, back working a module. And I know that was a bit higgledy-piggledy, but can you still hear me? Sorry, it just come up a network issue at my bottom.
No, yeah, we can hear you. That was fantastic.
No, sorry. I'll stop sharing my screen now. It just came up network issue, and I was like, oh.
That's always the way, isn't it, with team stuff? That was brilliant. So interesting. Thank you so much, Victoria, for that. So next up, we've got Diane.
Hiya. Just share my screen.
Okay.
So unlike everybody else, I've just got the one slide, so I'm going to keep it quite concise. But I'll talk you through my career journey and how I have ended up as a scientist today. So I didn't really know what I wanted to do through, I guess, high school and A levels. So my A levels were very much mixed. I did chemistry, I did maths, I did English, and I did psychology. So it's all pretty much all over the shop, and that's very much normal at that age. So when I started doing a lot of experiments in my chemistry class, I realised I really like chemistry, so I took that as my degree subject. So I did a master's in chemistry, and much like OZAK, it was at Loughborough University. It was then where I sort of started liking things to do with energy and, you know, trying to make our processes very much environmentally friendly. And that led me to do a PhD in hydrogen. So I spent about 4 years trying to make a technology that could produce hydrogen as in a green format. During that time, I worked with industry, but I was in a university environment, so I had exposure to both areas, and I realised I really like working in industry. It was very different to working in academia. So that sort of led me to apply to an industry job. So that was at a company called Johnson Matthey. At that point, I sort of moved away from hydrogen because I wanted to look at other energy companies. So this time, battery materials. So when Victoria showed you those battery packs, they contain active material, and that's what makes a battery work the way it does. So my job here at Johnson Matthey as a scientist was to create that material that can give us the power we need to power our appliances, or in special cases, even cars. So that was my first time sort of working at Johnson Matthey, and I progressed quite rapidly through my time at Johnson Matthey in the sense that I started working on producing material that can be used in Formula One cars. So you might have heard of something called Formula E, which is where they use electric vehicles. And the aim of that material was to look at high power. So I got really into the nitty gritty at my time at Johnson Matthey and looked at producing the right type of material that could be put into a Formula One car. And then I also looked at scaling this up on a factory level. Now, I really, really enjoyed this part of my job. However, I found that I was really much bogged down to the material aspect, and I didn't really understand the different types of cells. So that led me to take on a role at British Volt, which is where I am today. And here I'm learning everything from materials generation all the way to making your final battery material or cell. So we have cells at different formats. So on that picture, top right, we've got a cylindrical format, which is your typical Duracell batteries. But as Victoria showed you, you have different configurations. So I'm spending a lot of my time learning about that nowadays. My role throughout my career has been to learn and learn and learn. I find that quite rewarding, and I do that through keeping my options open. So that's been one of my biggest learning areas. Is if you keep your doors open, a lot of opportunity does come your way. I tend to stay curious and ask why. So if something doesn't work, why doesn't it work? And I did that through my GCSEs and my A levels, and that sort of mentality led me into a more sciencey field. The other one is when you're doing your exams, when you're sort of in industry or in academia, you're going to have a lot come your way. So it's important to be organised, but within industry, with a lot of things coming your way, it's also good to stay flexible so you are adaptable to the changing business needs and environment. So that would be my biggest bits of advice to you guys. But that's my career journey in a snapshot, but I'm happy to answer any specific questions should you have any at the end. Thank you.
Fantastic. Thank you so much. so interesting so far that all of the careers have really involved problem solving, which is brilliant because that's such a big focus of the science curriculum at the moment. So that's great to hear. Okay, so let's loop back to Candice and see if we've solved the sound
Can
issue.
you hear me?
Yes, fantastic.
Yes, good. Thank you. Okay, so I'm going to start at the beginning when I was at school, because I started, my GCSEs were pretty good. They were sort of all B grades when I left a long time ago, which is sort of the equivalent to your 6s and 7s now. And at the time we have careers interviews and they say, well, what are you good at? What are your grades? And mine apparently pointed to, oh, well, you're really good at maths, so you should be an accountant. So I went to college, did some A levels, did accountancy, maths, English and psychology. And at the end of those, I decided I didn't want to be an accountant. So I actually applied for an engineering apprenticeship after being sort of talked to by my dad, who was an electrical engineer. I've always followed him around, taking things apart and really enjoying finding out how things worked. Unfortunately, I've got no photos or anything of my apprenticeship and time there because it was an MOD establishment where I had to sign the Official Secrets Act. So my job was to actually work on weapons and missiles as an apprentice. So there I did 3 years apprentice training, where I completed at the end of it an NVQ3 at the time and a BTEC, a HNC in electrical engineering. I was the only girl there on the apprenticeship. There were 10 of us there. So obviously it shows how the difference in the number of girls going into that field is still very low now. And we obviously want to increase that and really encourage you to go in to do these kind of fields. Very low on engineers, so get applying, please. After I left my apprenticeship, I went and worked for a local council where we designed and built schools and houses, had a look at different houses and how they could be designed to be energy efficient and more sustainable. I was part of a team designing a local school, so I did all the electrical designs and I was in charge of contractors putting the electrical cabling in and designing them to be accessible and can maintain like the future of engineering and sustainability. So we had a look at, I think we were one of the first schools in the area to have solar panels. So this was nearly 20 years ago now. From there, I decided I wanted to work for myself after working with a team of engineers that were all men. I decided I wanted to work on my own and be an electrician. I did some more further qualifications. I studied for my electrical installation. I also did some pat testing. So I started up my own local electrical company and worked for myself for 10 years. And then I got to the age where I started a family and decided I think I want to go into teaching. So I've still carried on my self-employed status and my company, but I had a look into sort of teacher training and having a look at hopefully teaching like the next generation of engineers as well. So that's what I'm currently doing now. I'm working as a technician in a college, which allows me to maintain and support the learning in classrooms and apprentices as well. And I'm currently doing my teaching qualification, but continuing to do my own development. I'm also, once I finish my teaching qualification, I'm going on to do my HND, hopefully starting next year. So all the way through this, I still continue to learn, continue to do courses, because your learning doesn't stop at the end of school or college or university. It doesn't matter what route you take, you will want to learn. And we're always asking those questions and problem solving. And to do that, we need to teach ourselves and teach others as well. So I think it's really interesting that all of you have done your research, and it's all really interesting to me as well, because listening to you, I want to learn more about batteries and about cells and things like that, because that's what I will be teaching as well. And as technology moves on, we don't know what jobs are out there in the next 10 years, so it's quite good to keep up with developments. So yeah, that's where I am now. And the maths, we use it every single day. So electricity and engineering is here every day, lots of formulas, you need to work things out. We're always constantly looking at sine waves, signals, forces, all sorts. I also teach the mechanical side of engineering as well, so using hand skills, and there's lots of maths in there as well. So yeah, that's me in a nutshell.
Amazing, thank you so much. That's another really interesting contribution there, so thanks a million for that. So we haven't got any questions from students yet in the chat. So teachers, if you've got any to add, please do. In the meantime, I'm going to ask some of my own questions of you. So let's just go around the group in the same order. I'm going to ask you, what is the most exciting or interesting part of your job, and also what's the most challenging part of your job? So we'll start with Candice this time and go around the original order. So the most exciting or interesting thing and the most challenging.
I think the most interesting and exciting thing, I think, is seeing other people learn and actually seeing that light bulb moment. So when we're looking at setting projects and they understand, they do their problem solving, it's great to see them actually understand. I'm sure all the other teachers will say the same thing. But knowing that you've also used your knowledge and sort of embedded it into their thinking and seeing them use it in different ways. The most interesting thing is the speed and the advancement of technology that we're now using in the college. We've had a delivery of robotic arms recently, and we're at the moment programming them to do specific tasks. And I know these are available in factories at the moment, but looking at the future, we're going to be teaching the future generations of how to do this. There are lots of things that I teach that I didn't know about a few months ago, so I'm still continuously learning, and it's the skill level that we will need for the future is going to be high. So yeah,
you do hear a lot of people say, especially in the field of education where we work, is that a lot of the students we're teaching now will be working in fields that don't even exist at the moment, especially in science, where the sort of knowledge and technology is evolving so rapidly. Students on this call who go into a science career might be working with science or equipment or technology that we don't even know about yet today. So that those skills we develop in school of problem solving, you're applying those skills to try and learn new things all the time later on. So that's super interesting to hear you talk about that. OZAK, what's the most exciting or interesting thing about your job, and what's the most challenging?
The most exciting thing about my job is innovation. So I'm always working on something really new and advanced. So in our company, I work in the corporate research. So it's usually looking at solutions in the pipeline for the next 10 years. And another exciting thing about it is that it's always collaborative. I never work alone. And that's something throughout engineering. It's about a team effort and a collective effort. And I really like that a lot, because you get ideas and different people's opinion, and it shapes the final solution into something better than you would have achieved on your own. I'd say the most challenging thing is also keeping pace with this technology and the innovations happening. They're happening so fast. Like sometimes I just need a minute to just catch up on everything that's happening, because whatever's happening outside in innovation, whether it's in research happening in universities or in other industries, it does have an impact on the stuff that I work on. So I have to dedicate quite a lot of time to actually researching and reading what's out there. Kind of like what Candice said about relearning and developing new skills as things change constantly. I'll say that's the challenge, but I enjoy it. So that's why I keep doing it. And the moment I don't, I would find something else, but I doubt that would ever happen.
Amazing. We actually have a question for you, OZAK, which is, you studied in both Nigeria and England. Were there many differences in the education, and what motivated you throughout your time in England?
So in Nigeria, the only difference is we don't have A-levels as part of our educational system. After high school at 16, we go straight to university, but our university courses are 5 years, not 3 years like it is in the UK. So we would end up graduating the same time. But for me, because of frequent strikes in the academic calendar, so either students are on strike or lecturers are on strike because they're not being paid well by the government, a 5-year course could become 7 or 10 years. So very early on, my parents started saving towards my education because they knew it made more sense for me to go abroad to study for my degree. I chose the UK because it was an English-speaking country, and also there were no guns. It was the comparison between the US and the UK, and the UK seemed like a safer investment. Also, the courses were shorter. They were 3 years rather than 5 years like in the US, which would be significant, should I say, money or finance from my parents, because we don't get student grants. Our parents fund our degrees. So yes, those were the reasons why. So it's very similar system. The UK obviously is a form of, it was colonized by the British, so our educational system is quite similar. There were no huge differences. And what motivated me throughout the time, I just felt privileged to have that opportunity, you know, to be able to come to a new country, to go abroad and study. I made the most of it, and being in university, meeting people from all over the world. I think that's a great credit to the UK's educational system. You have people from everywhere in the world. I made friends from all parts. Until this day, if I want to travel anywhere in the globe, I know somebody there that I could still reach out to. So that's a key benefit of university and my experience, personal experience. But I get it's not for everybody. But yeah, just being afforded the opportunity to be able to study and pursue my passion. Not everybody is that fortunate. So that motivated me to want to really work hard and do well in my grades. And stuff I struggled with, I practiced harder. I wasn't really great in all the subjects. I came in with 3 C's in my A levels. So I knew I wasn't the best or smartest student. So I made sure I made friends that aligned with peers who had done really well in different courses. There are always people who know things better than you or are smarter than you. And if you align yourselves with those types of people, they motivate you as well to want to do better. And that's how I was able to graduate with the first class and then go on to do my PhD.
That's quite inspiring, actually. And that's one thing, actually, it's a misconception I find often working with students, where they think that to go into a science career, you need to be the best, you know, you need to be a straight A student, or you need to be amazing at science or maths. And that's absolutely not the case. There are so many different types of science careers, and like you've all mentioned, throughout your time in that career, you'll be learning and developing all the time anyway. And so really those grades are about getting into the course you want a lot of the time, and not necessarily about how suited that career is for you. So don't let it stop you if you aren't getting the best grades in science. Often isn't a barrier. So we'll move on to Victoria. Same question to you. There's also a question in the chat for Victoria, which is asking about the process in designing the cell that you held up, and did you work with other companies to design that?
So I'll do how our cells come about first. So like Diana and OZAK, they work in R&D. So my job as an engineer is basically that R&D give us the blueprints of this is what you want us to make. And they've made 1 or 2 in a lab. And then as an engineer, what we have to do is we have to scale that up to the size that we are. So if you imagine R&D's idea is, we know that we can make this 1 cell, and it's took us a month to be able to hit all of our quality concerns. For us, we then go, okay, but for us to make money, we need to make 1 of them every 17 seconds. So my main job is, how can I get this line running a little bit quicker? So we developed our first cell alongside Nissan. We used to be part of Nissan, and then we work really, really closely with our other the big brands that you see there. Like our sister plant in the US worked really closely with Mercedes to design their battery. But it really is R&D, do the design, and then process engineering, take that design and go, okay, but how are we actually going to make this work? Like, it's well and good saying that in a lab we can do this, but does it actually make any money? How quick can we run them? How many can we get out the door? What actual problems are you going to have when you're making these at scale? Like little things like this is an empty container of a cell, but these are actually about 8 kilograms big. We have to do work on how are these going to be picked up? What robotics do we need in? What's the safety implications of 1 drop? But like, as you can see, everything I'm saying is a question, and that's all engineering is. Like, as engineers, you look at a problem, and then in your head you've immediately got a list of 50 things that could potentially go wrong, and then you say, okay, well, I know that I can speak to safety about the handling of it. I know I can speak back to R&D, and that's what, for me, that's what engineering is. I don't know the answer, but I'll find someone who can. So the most rewarding part of my job is also the most challenging part of my job, is that I'll come in this Monday morning and I don't know what's happened over the weekend. We're a facility that runs 24/7, and we can have some car crashes overnight, and we can have some really good wins overnight. So every single day for me is different. We've got new trials going on at the minute. We've just commissioned a new line a couple of months ago, so that's still in its teething phases. Every single day I'm very, very what's the word? Independent in terms of what I'm working on. I don't come into work and someone doesn't give me a job. So I come into work and go, okay, but what does the business need me to do today? Which is a scary thing, and it's a exciting thing, because you go through school being told what your day is going to consist of, what homework you have to do, what's on the curriculum, and then you get put in the wide world and it's like, okay, well, you need to work it out for yourself. So engineering is just that independence to be able to, like, okay, but how are we going to actually make this work? And it's the motivation to keep going behind those. So I hope that answered the question. If there's any more, please, it's better if you ping them in the chat than it just being silent.
That was brilliant. Thank you so much. That was great. Yeah, you did answer the question. So I'm going to move on to Diana. And you also have a question in the chat, Diana, which was with regards to the hydrogen made from the initial company you worked with, what was the hydrogen used for?
Yeah, so the hydrogen was actually used in various applications. So we were looking at applying it to boilers. So we worked with Bosch on that one. We thought about putting it in the main grid. So National Grid were working with us. So we, like I said, we kept our doors open and we let people come our way. We tried to stay flexible, and we found that a lot of business did come our way when we sort of were quite flexible with what our application was. But we're doing the same thing at British Volt, keeping our doors open, talking to loads of different, car manufacturers to say we can make whatever cell you want us to make, and that's what we go for, and it works. So I tend to embrace the same sort of philosophy with the way I live my life as well.
Amazing. And so, Diana, what is the most engaging or interesting part of your job, and what do you think is the most challenging part as well?
So the most interesting would be very much like what everybody else has said. Every day is different. We come with new problems. Our company, well, we're sort of a startup, but we're sort of expanding quite rapidly. So we're always talking to so many different people. So every day we've got a new challenge, much like what Victoria was saying. You come in and there's either something that's gone wrong or something that's gone really well, and we're trying to sort that out. In terms of most challenging, I'd say with technology developing, you're expected to keep up with it, and by doing your day job and also keeping up with new developments, it can be quite tricky sometimes, especially all the jargon that comes with it. So when I moved from hydrogen to batteries, I was on Google all the time, and I still am. I'm trying to learn what all these new words mean, so that's quite challenging, but it's fun. I like it.
Amazing. So we're almost at the end. We've got about 2 minutes, but so I want to just take this last question from Alison, which is, lots of inspiring careers and routes into them, but how did you find out what to study, and where did you find your jobs? So I'll give each of you a chance to answer that, and then if anybody has any other questions, please pop them in the chat, and we'll ask the speakers to maybe respond in text in the chat, and we can make sure everyone can see that as well. So let's just go quickly around in our 2 minutes we have left and give everybody a chance to answer. How did they find out what to study, and where did you find your job?
So this is going to make me sound really, really old, but my apprenticeship was advertised in a newspaper, which I applied for a long time ago. And it was kind of an advert for an open day. So I would suggest going to lots of open days. If there's something you're even slightly interested in, go to an open day. Lots of companies have them, lots of colleges have them. And you can really see what it's like to actually be in that workspace. And I remember going along and thinking, yeah, I really want to work here. It feels like a nice place to work. It's really interesting. They do what I want to do. They take things apart, they maintain things. They solve problems, they fault find, and it's everything I'd learned from my dad and from school when I was that little bit younger and through college. And then the qualifications that came with my apprenticeship, so that I was put through those and through all my electrical engineering qualifications. And then from there, it sort of urged me to go a little bit further. So every qualification I did after my apprenticeship was off my own back, and I paid for myself. Which is also a benefit of having an apprenticeship, is that it's paid, it's a job, so you can actually afford to do these things. I bought my own car, paid for my own qualifications after that, and it's kind of gets you on the job ladder earlier than sort of having a degree, really.
Amazing. OZAK has shared a link for us. Thank you, OZAK.
No worries. So for me, I just knew the problem I wanted to solve, which was the problem of electricity. And it was my parents and my tutors that helped me make that connection, that I needed to what I wanted to do was electronics and electrical engineering, because that's what would enable you. Chemical engineering was also shortlisted, but I remember chemical engineering being very focused on oil and gas in Nigeria, and I didn't want to be part of oil and gas. So I went with electronics and electrical engineering. So yeah, it's parents and tutors that helped me make that connection. In terms of my job, when I finished my degree, I just went on the graduate job website, the Institution for Engineering and Technology has a careers page or job page that advertises like vacancies. So I found Condor on there and applied, but every job after then has come through LinkedIn. So my current role in Switzerland was headhunted from LinkedIn, and that's how I arrived here in Switzerland. But there are many careers websites. I'll put the links in the chat for teachers to dispense with your students that tell you the different routes available to you, especially for the UK. There's so many resources, but I'll keep typing and let somebody else speak.
Amazing. Let's go to Victoria next. Sorry, I'm very conscious we're over time. So let's, after this, we will finish after Victoria and Diane have a chance to share their answer.
So I got into engineering because I was told that I was always really argumentative at school. So I would always be in a chemistry class or a physics class, and I'll be like, okay, but what is the point of this? Why am I doing this? Why have I been told to solve this equation? What does that actually matter? And I was told by my chemistry teacher at the time, they were like, please don't ever get anyone into research. Like, that's not for you. You need to be in a real world where this is a real problem to solve, and you'll be able to see the output of what you've done. So I'd then done chemical engineering, and then I'd done the same at uni as well. I was sitting in my second year of uni and went, okay, but what's the point of this? I'm still solving equations. I'm still working in the hypothetical. So that's when I decided to start looking for jobs. Obviously, I'm from the northeast of England, and I'm not sure how much the rest of the country's aware of it, but Nissan is the whole northeast. We indirectly, Nissan employs 30,000 people. So for me, it was kind of like a no-brainer. So I just applied as a placement, just like everyone else, and it kind of stuck. I started at Nissan as a placement, and then they said, what does it take for us to keep you and never leave? So then I ended up working both at the time. Basically, I haven't had holidays since I was about 18. Whenever I wasn't at uni, I was at work. Whenever I wasn't at work, I was at uni. But it really worked for me doing both. Just because you get a feel of like, what is actually the point of studying all this? I know through school, I really, really struggled with, this is all well and good, but where's the job at the end of this? But in STEM, there definitely is jobs. I actually ended up on GCSE Bite Size last week, looking at a reaction that I'm going to do at a lot bigger scale and try it next week. So just know that some stuff that you're doing in the lab actually does pay off, and we actually do need to use it. But yeah, I hope that helped.
Amazing. Thanks, Victoria. And finally, Diana.
Yeah, so the way I sort of found my way into my degree, I guess, was I didn't really know. As I mentioned, I liked a load of different things. I was more interested in English and psychology, but when I got the experience of actually being in the lab doing experiments during my A-levels, that's when I really found out I liked chemistry. So if you're unsure, just do a bit of everything. And that sort of led me into university. At university, realised I really liked the energy-based modules, so I sort of specialised in that, and I sort of just got to find where I am today through just experimenting. I found my first job through a careers fair, so that's really useful at university. Do attend them, even outside of the university environment if you get the chance. They are really useful. So yeah, that's me.
Amazing. Well, thank you all so much. I absolutely loved listening to your stories, and I'm going to go and Google loads of things about your careers in a bit because I just found them so interesting. I hope the students on the call found them interesting as well. And thank you so much to the teachers for signing up. We have the next webinar in this series, the partnership between Science Mastery and Founders for Schools, is on the 11th of July, and it's about STEM to save the planet. So we'll be listening to scientists working in careers related to things like climate change and anything else related to sort of saving the planet, and it will be a similar setup with a panel. So please do look out for that event on Twitter, and you can find that on the Founders for Schools account or also the Science Mastery account, which is @Science Mastery. So thank you so much everybody again, and have a lovely evening.